Hello everyone, welcome to my 100 most popular algorithm series. In this particular video, we are going to cover Leetcode problem number 70, which is climbing stairs. Let's understand the problem statement. So here we are given a staircase, we want to climb it, and there are n steps to reach the top. So we've given n, which is the number of steps to reach the top. Now the conditions are we can take either one step at a time or two step at a time, like we right in one particular climb we can cover one step or two step. So what we are required to do is how many distinct ways we can reach to the top, to the end step. So for example, if we're given two steps, we can climb this two step like in one by one, so one step at a time. So that is one way. Or we can climb this two step directly from zero, we can directly go to second step. So there are two unique ways to reach to the top. Similarly, in the example 2, we given 3 stairs. Now we can climb this using 3 different ways. One is we can go one by one, so one step, one step, one step. Or we can take first step, one step and then two steps, or we can take two steps and one step. So there are 3 different distinct ways to reach to the top in this particular example. Cool. So these kind of problems, distinct ways and everything, typically dynamic programming generally helps a lot. So we can solve this problem using dynamic programming. So I'll explain you the solution here. So in this example, I've taken 5 steps. We are here at the moment. At the 0th step, the person is standing here. So the way we can solve this is, in DP usually we have some base cases, right? So here the base cases there are 2 base cases. So one is at this location, at the 0th location, what the person can do. It can do 2 things. Either it can take first step or it can take second step. So in DP again, let's solve the smallest possible sub problem first. That is, what is the unique ways a person can reach at the first step. Let's say if n would have been 1, then what is the unique number of ways to reach here? Now the person has only one option, that is to take one step. So the number of ways to reach here is 1. Now let's expand the problem a bit. Let's say if n were 2, now in that case, what is the unique way to reach to this location? Now the person has 2 options. It can either jump from 0 to 2, which is one way, or it can take one step at a time, that is to reach here and then reach here. So there are 2 ways to reach here. Great. So we have found the base cases for our DP. Now let's extend this logic. So for example, if n was 3, then what is the unique ways to reach here? So at this position, the person can reach from 2 points. Either it can take this route, because from here it can take one step, so it can reach from this route, or it can take this particular path. From 1, it can directly jump to 3. So to reach here, there are 2 ways. So the number of unique ways to reach here is the number of unique ways to reach here plus the number of unique ways to reach here, which is 3. Similarly, if n was 4, then the number of unique ways to reach here would be, because from here you can reach from 2 or you can reach from 3. So the number of unique ways to reach here is this plus this, which is 5. And similarly, number of unique ways to reach to 5th step is this plus this, which is 8. So this is the logic we can use. Our task is to use, this is the DP array. So our task is to populate this particular array, and whatever is the last number that gets propagated here, that is our answer. Cool. So let's solve this problem. As always, we'll do some sanity checks for our inputs. So if we have no steps, then we cannot find an answer. If we have one step, then we know the answer is 1. If we have 2 steps, then we know the answer is 2. Those are the base cases. Then the next step is we will have our DP array. The DP array will have initially all zeros, and we have n length of it. The length of the DP array will be n. So this is the DP array. The length of the DP array is same as the number of steps that are available. Now for the base cases, so we need to add DP base cases, as is the norm in every DP solution. So we'll add. So the first base case is this, the number of unique ways to reach to first step, which is 1, and the next base case is the number of unique ways to reach to this particular step, which is 2. Cool. So the rest of the DP items, we will populate in loop. So start from the second index, which is the third step, because we have already populated the previous 2, and will iterate till n. Now in every iteration, you know that the number of ways to reach here is the sum of the previous 2 DP items, right? So that's exactly what we are going to do here. So DP of I is equal to the number of ways to reach to 2 previous steps. So the number of ways to reach here, unique ways, is the sum of number of ways to reach to 2 previous steps. So this will populate a DP array, and all we have to do at the end is return the last number that gets populated here. So let's run our code. Great, it was accepted. Let's try with a little difficult example. 5 steps. Oops, the code is not working. Let me check. We have made some mistakes. Let's verify it. So where is 1? Where is 2? We have the DP array of n items. Oh, oops, this should be 1. Yeah, it got accepted. Let's submit our code. Great, it worked. So yeah, that's how you solve this problem. It's a dynamic programming approach. I hope you like this challenge. Stay tuned for more challenges like this. I'll see you in the next one. Bye.